telescope, since it is going to be in deep space, it's going to be exposed to really, really cold temperatures. And so they fill the chamber and the walls with liquid nitrogen, and they cool that chamber down really, really cold. And in fact, I'm going to give you some sheets. Let me see. That explain how cold it's going to be. Here it is. Liquid nitrogen is very, very cold. It boils, so think about when you make your mac and cheese and how, you don't want to touch it, it's super hot. This stuff is boiling right now at, I'm not talking Fahrenheit because you understand that, negative 320 degrees Fahrenheit. So that's super cold. We're going to talk in Celsius in here. So from now on, we're going to talk about water boiling at 100 degrees Celsius and freezing at 0. But there's another temperature scale, that you'll hear in high school and more in college if you go on to science, and that's the Kelvin scale, and that's on the board.
Oh, my.
We don't do a whole lot with Kelvin, but we did learn about absolute zero, right? And you guys showed me in the dance. So Kelvin scale, what's unique about the Kelvin scale is that its bottom, lowest temperature is 0. So that's the true 0. And so we base everything off of that. Like you know that water is going to boil at 100 degrees Celsius. On the Kelvin scale, it's 375. Absolute zero is 0. That's 0 on the Kelvin scale. Just to give you some perspective, nitrogen is going to boil at 77 degrees Kelvin. So that's really, really, really cold. So we take things like the James Webb Telescope, and we need to get a chamber on Earth and have it mimic deep space, because we want to know if these instruments are going to work in this really, really cold environment. Because it's millions and millions of dollars to make this, right? We don't want to send it up there and have it not work. So they use liquid nitrogen like that. That's one way they use it.
Can you write that?
You don't need to write that, but in the chart, you're noticing that absolute 0 is 0. Nitrogen is boiling at 77. Okay, so last night you watched a video and you noticed this graph. So let me bring the time back to 0. This is kind of out of order for me. I did it today, not just because your parents are here, but because I skipped. I tell people, but I skipped the crazy races, saved my eardrums for the day. But it allowed me to go to a special gas plant that they have liquid nitrogen, and I was able to buy it. Now, you can't just go there and buy it yourself. Number one, you're not 18. I think you have to be 18. Number two, you don't have the type of job. In fact, they give me a little bit of hassle, but I always see the same guy and he hooks me up. But I have these special containers. They're called Dewar Flasks, and they're kind of like ice chests with really thick insulated walls, but they're specially designed for stuff like cryogenic liquid. Cryogenic liquid would be like liquid that you use to freeze things. In fact, on the ISS, they have a lot of some of the chambers are scientific research chambers, and they'll have different studies going on, and they'll have liquid nitrogen in that laboratory area of the ISS. Yeah.
Is it dangerous to have liquid nitrogen in space?
Thank you. Oh, in space. It's dangerous to have any kind of gas in space, because we know from the gas laws, what happens if you trap a gas?
It gets really angry.
It gets angry. It gets angry, like it's got a personality. It could have an explosion. You can have an explosion, right? So, especially with NASA, they have a lot of smart people working for them, and they really have to do worst case scenario. What if, right? So they have to vent these gases, because if they don't vent the gases and they contain it, which we're going to do today, you could get an explosion, right? So let me show you my car this morning. This is my car. I took a picture and emailed myself because I don't get enough emails, and I wanted to email myself. Just kidding. This is a picture of my car, and I have my baby strapped in, right? I went really early this morning, got my liquid nitrogen, have my little, crate down here. This stuff's always boiling, and you notice these tops come off really easily. This is not a screw top, it's just kind of pushed on, and then it kind of freezes throughout the day. But it's not a screw top for a reason. In those little containers, like these right here, this has a very easy removable top, and it's got a little vent there too. Why do you think we got to make sure of that? What do you know? What's going to happen if you trap a gas that's expanding? So you guys see that picture? Yeah, so you're going to get all three, pressure, volume, and temperature to rise, and you'll get an explosion. So I strap this baby in, kind of held onto it and kind of slow. People were honking at me because I'm like accelerating pretty slow out of to a green light, so I didn't want anything to spill. Because this, he filled it up pretty high, and any kind of jostling would spill it. Now it just vaporizes, but I have a leather chair right here, and I had to put a pad down because I didn't want this to freeze any of the mechanisms. Because I got like some kind of, everybody has like movable chairs and components. You didn't want it to freeze. It could like disrupt the mechanics of it. Yeah.
I'm just confused why does it already boil at such a low temperature?
I will show you.
Does that like hot boil?
Let me show you something. So last night you were watching the video and we talked about solids and how as time goes by the kinetic energy, you guys did your dance, kinetic energy gets higher. It hits that plateau, and what's happening at that plateau? It's changing into a liquid, so all that energy is going to break bonds instead of raise the temperature. And then it gets into the liquid form, and the particles are moving away and shaking and getting more space. Daisy's already doing her flow. And then we get to that special magic number for that substance. If it was water, it'd be 100 degrees Celsius. But for nitrogen, it is what in Celsius? Where does it boil in Celsius?
Negative 196.
Yeah. So negative 196. That's when it would start to boil. And that's when it would change to a gas, and then all of a sudden, now it's a gas, right? So we're going to focus right here. And let me show you this next slide. Right here, we got two vocab words that I wrote down. Endothermic, was it on the video? Endo, exo? No? Okay. Here's how I memorize these two terms. Think about, thermic means heat. You guys know that, right?
Oh, it's already on here.
Yep, it's already on there. Maybe you want to highlight or something. Thermic means heat. Endo, you hear N, you hear inside. I hear inside. Yeah? So it means to absorb energy. So you're going to do a dance on Monday. I won't make you do it today. They're like, don't make us dance on Parents Visiting Day. But endothermic means absorb. Going to do a little roll. Absorb to break. Absorb to break bonds, right? So what this is doing right now is anything it interacts with, the air, the container it's sitting in, it's absorbing the energy from that container and breaking bonds and going into the gas phase. But something's got to release that energy. Okay? So for instance, do you know do you know what compounds in your body that takes up about 80% of your body? Water. Water, good. So, water is essential for life, right? We have an organic substance here. You're organic. Anything that's living is organic. So this substance has cells. And cells are primarily water. Because that's just what it is. How it is. So I'm going to show you what would happen if I stuck my hand in. So I have cells in my hand, right? And they're primarily water. Something's got to release energy and something's got to take it. And since this stuff always wants to take energy, because its boiling point is so cold, here's what would happen. Well, let me show you what it looks like first, and then I'll show you what would happen to an organic substance. So I have to wear like pretty heavy gloves when you're dealing with it. I'll put it in, let's see. Leftover stuff. Okay, we'll put it in here.
Is there anything in the
It has about this much left from the other classes.
What's in the gray one?
That's liquid nitrogen too.
Oh, okay.
And then I got two little cylinders down there, but I got one more class after you. So I have to play my cards right. So you can see it's clear.
That's so cool. It's
So
boiling.
it's clear. It's boiling, but it's super cold because it boils at a very, very low temperature. This is just going to feel cold, so don't freak out about your legs. So you can see it forms little droplets. And if I went like that, it just vaporizes.
What? What? Oh, because it gets so hot that it...
No. Well, oh yes, it is hot. It thinks it's hot. Let's give it a personality. Nitrogen thinks it's hot, right? But it's super cold. It is boiling at a very cold temperature. So it forms droplets, kind of, because it's got that property of surface tension. And what you see, all that like smoke, which is not really smoke, that's the air. That's the air giving energy to the nitrogen. And the air is condensing. That's why you can see it. It's condensing because it's giving energy, it's releasing energy, and the nitrogen's taking it in. So what you're going to take notes on the back is you're going to just write a couple things. It's pretty much repetitive. I just change what substance is giving energy to the liquid nitrogen. Because liquid nitrogen has the lowest boiling point out of any substance in this room. So it's going to win the tug of war for energy. It's going to take the energy. So, hold on. If I take my hand and put it in this beaker, this could kind of represent that. We have an organic substance here that has cells that are made of water.
Ooh.
This is a real flower, by the way. I should have you touch it. The liquid nitrogen is taking the energy from the flower, taking the energy, taking it. The flower is releasing energy, releasing energy. If I did this, my cells would freeze, all the water would turn to ice, it would slash through the sides of the cell, slicing the cell, and it would kill the cells. And that's when you would get the black fingers and all that. And it's dead. Those cells are dead if it's really extreme.
Oh.
So I take it. Oh, so you can hear it. You can hear it?
So cool.
Crazy, right? If I take this, it has air in it, which has energy, right? So we can, let's see. This is a real plant. I took it out from the hallway. Don't tell Mr. Bars. I'm like, I didn't buy any carnations. So I just took it from open house.
Something like that. It sounded like glass.
So again, real plant. If my hand was in there, I would shatter my hand. I could shatter my hand. In fact, when I went to a conference, the guy had a sausage in his finger. And he's like, if I put my hand in it, and we're like, what are you doing? And then he takes the hammer, and he goes like that. And we're all like, he had a sausage in his hand. So, did you hear it? It sounded like glass. But, you know what's funny? This is going to start gaining energy from the table and the air, and in about 2 minutes, this will be back to normal.
So why does it not help? Why doesn't your hand go back to normal?
Because the cells got broken. The cells, they got ripped open. So we'll just get rid of that. This is a lovely day for clean room. Okay. Okay, so let's do this.
So cool.
Let's take, now this is Pyrex, and it can withstand a lot of temperature changes, but I have broke it in the past. This is your normal racquetball, so you would write, it's cracking, these are cracking, because they're gaining energy back, they're cracking a little bit. So you're writing down flour, released energy, exothermic change for the flour. It has a lot of heat energy stored in just the organic compounds it's made of. And the liquid nitrogen takes in the energy. So the liquid nitrogen's endothermic, and when it takes that energy in, it's gonna go to this gas phase. It's gonna vaporize, and now it's all in the room. When you breathe, when you take a breath, 75% of your breath is nitrogen. And it just comes right back out. It doesn't hurt you. So 78% of the atmosphere is nitrogen. Only 21% of the air is oxygen. Right? So we got to be careful as a population of humans to take care of the atmosphere, because if the oxygen levels dip down to 19%, we would all die. And if they raise to 25%, we would all explode. Isn't that a pleasant thought? Here's our rubber ball, right? Emma, is it a rubber ball? Yes. Okay, don't hit the smartboard. Okay, good. All right, so what we're going to do, and as we wait for that to go, you guys see a plastic, yeah.
Wait, so the flour released the energy because the liquid nitrogen absorbed it?
Yep.
So it was breaking bonds when it released the energy? Or
no, it was making
I just don't get...
Okay, so here's the dances, Alex, you're going to do on Monday. You're going to absorb to break. So this is absorbing to break bonds. It's going to get the energy to absorb from anything it touches.
To break.
And then the other objects has to release to make, so you become a solid.
And Okay,
So this thing became harder. The
So when
particles
you release
slowed down and
energy,
came really close
you
together.
make bonds, and
It
when you
released
absorb
energy
energy, you
to
break
form bonds and to get like more solid. It went down the graph.
Okay.
Okay, so what we're going to do is we'll take that bouncy ball, and as we're waiting, we're going to deal with this. Okay. All right, I'll give you warnings for any kind of sudden noise. So we're going to take
you
this,
absorb energy,
put it in there, we'll put a little bit of this in there.
release energy to break them.
Like Alex has to be warned.
What?
Oh, it's Daphne. Oh my gosh, Daphne with the pop can. It was pretty funny. Is your mom here? It was really funny. Okay, so we're gonna put a little bit of this in there.
I'm so scared for the sound.
Y'all have goggles on in the front row.
Oh God.
Okay, we're gonna make a rigid container. So you know what that means, right?
Oh, it's gonna pop. It's gonna pop. Hey, what is it? Liquid nitrogen?
Liquid nitrogen, just in the film case. It kind of startles me because it does it whenever it
The
wants.
temperature's increasing, the volume's increasing.
Yep.
Oh my God. Wow.
You want to do it again? Yeah. It's kind of fun that it's like, I don't know when it's going to happen. And then it's just, do you see the cap?
Yeah.
This one's better than the black one. These kids don't even know what this is. Right? The kids don't. I have like a ton of them. They're like, what's this? Like you can't even buy them anymore. You have to go on Amazon and it's funny. I used to be really big into developing my own photographs. Okay, ready?
Oh God.
Wait for it. Wait for it.
I'm gonna try not to react.
It's like it's under your chair. Okay, who's skittish? You're skittish, so warning.
Oh, it's cold.
Like, yeah, because it just gave all its energy. All right, skittish one, be prepared. This is kind of, your eyes. You'll be fine. Maybe go like this. You'll be fine. I'm doing it right here.
Here's the extra.
Oh, yeah. You want to put them on?
No.
You guys got glasses. It hasn't done anything. Okay, so physical properties of the rubber ball. We got bounciness, it's squishy, right?
Malleable.
It's malleable, right? I can't get it.
Because the temperature increased, the pressure increased, and the volume increased.
Yeah, that's
Ready?
what I put too.
It's not breaking fully. I probably need to cool it
There's a
down
piece
even more.
there. Can I pick
So
it
it's
up?
broke, but there.
No, it'll freeze my hand.
All right. Okay.
I don't get this.
Let's see what else I do.
I don't get like how it absorbs energy. Like,
Oh no,
when
I
it
don't
was-
pick it up.
Oh,
We'll put a couple,
I don't get this.
some good marshmallows in there already.
Wait, why are they? Is it because it's so cold?
Okay, so again, the racquetball gave its energy to the liquid nitrogen.
So there's no more energy in this ball?
What?
So it's not really bouncy anymore then?
No, but if you grab like this piece right here, if you grab these pieces and just watch for a little bit, they're going to start to absorb the energy now from the table.
And they'll
So they're
become
breaking
bouncy
down.
again?
Remember how I told you it's very difficult to obtain at
They're
fluid
making
zero?
bounce.
No.
Because you're going to be always gaining energy from anything
No,
you
absorb
touch.
is breaking.
So this will
Isn't it?
Wait,
this will absorb energy from the air.
so they're making bonds?
What is?
The ball's
This
making
is
bonds.
because
The
it's getting
table's
harder.
the table's
The
breaking
particles are slowing down, like in the particle dance. Particles are slowing down. Okay. Let's see. That what's happening right there with the marshmallows is it's giving away its energy to the liquid nitrogen.
Wait, so marshmallows are in the...
Yeah, the
bonds.
beaker. Yep.
It's in here today.
Oh, that was
So
dry
now
ice.
You're gonna film.
Nope, no dry ice today. All right, so my children are super into Star Wars. And they're like, Mom, what are you going to be for Halloween? I'm like, what do you want me to be? And they're like, well, it's got to be Star Wars. I'm like, well, I'll be Princess Leia. And they're like, no, you need to be something better than that. I'm like, okay, what do you want me to be? They're like, we want you to be an animal. I go, well, what animals in Star Wars? And they're like, we want you to be an animal. I'm like, I'm not going to be Chewbacca. That's not going to happen.
That'd be so funny. I can so see you.
You should be one of the little people.
So they're like, we want you to be... we want you to be a dragon. I'm like, a dragon? Yeah, we want you to be a dragon. I'm like, okay, I can make that happen.
Oh my god.
I can blow smoke and be a dragon, right? Yeah, okay, good enough. I'll let you be a dragon. You want to be a dragon?
Yeah,
I want to
Yeah.
be a dragon. I'm really going to be Princess Leia. I'm not going to be
That was all part of the story.
I just bought my wig yesterday on Amazon. Now, this one, okay, I got a confession. The reason why you're getting a marshmallow is because well, it's fun. But those things they're really, they taste bad. I gave it first hour and something's wrong with them. Maybe because the expiration is really. So I'm not going to give you a grand. You can let your parents have one. You can be nice. For your dad. Don't forget I'll make more.
There's some flowers in it. Well, I'm totally going to be in it.
What are you doing? We're gonna selfie our dragon. Oh my god.
In fact, my kid was a dragon in your class
Yep.
back in the day. They're all flower petals.
Of course we
I'll get you some. Hold on.
You're so weird. You're so
Oh, gross. That graham cracker is really bad. Are you doing my time?
Yeah, it is 12:23. So you have 7 minutes.
7? I can teach all day.
We could stay here all day.
Yeah.
I've always loved something.
I love that is
Your death penalty.
These are really gross. You're not going to eat that.
Gold.
Okay. Okay. Oh, we have
Can you blow out?
Oh wait, I walked.
No, wait, we didn't get.
We're going to...
Oh, sorry. I thought you were putting the blow out.
I stepped up. So let's
Yours
see.
doesn't do anything.
Is the flower soft?
The flowers are soft, so when you leave today, feel them. These are getting softer. I'm going to take this balloon. I had a funny thing first hour, but it
I'll
popped.
just take a video of it.
We're going to just... My goggles on. So did you see that balloon?
Yeah.
It had energy, right? Come on. There's like this much left. Now watch. Ready? Look at my balloon. Now watch the balloon. Are you getting this?
Yeah.
Okay, we can do it again. I got it on no problem. I have editing skills. I know how to edit.
I got it.
We'll do it again. We have energy in here. Normal balloon has energy from the room.
Miss Smith, where's your gloves?
Well, it's way down here. I am being safe. Thank you. I can't grab these tongs with these big fat gloves on. That's why I'm using a tong. So now what's happening? Now which one is endothermic? Which one's absorbing energy now?
The balloon.
The balloon. And what's giving the energy?
The air.
Air. Good. So we'll leave that there for a minute. Okay. Got a couple more right here. And then we'll make some ice cream. That's the best part, right? There you go. Whoops. They're going to be so sad they didn't get any. Okay, I'll give you a couple.
Oh, they're cold.
Oh, you grab them off the floor.
You can't see it.
Oh, it's pretty cold.
They get really... Where'd you go?
Wait.
It might be on the other side of I like asking the ice cream.
Oh my god.
Oh, yeah,
Crispy.
got that.
Oh, it's already the beginning.
That's
I'll get some
for
more
me.
for you
That's
guys.
good.
For you, too, for me, nice. You're going to help too.
That's a
Okay, I gotta grab it.
Oh, these don't work.
It worked for me so much at one time.
Alright, so if you're allergic, listen to the ingredients. It's got half and half. Who's allergic to milk, it's got half and half. You'll have more marshmallows. And it's got vanilla. Anybody allergic to vanilla? And it's got sugar. It's a lot of sugar and a lot of half and
Is
half.
it like aconized?
It's liquid nitrogen ice.
Oh, that's even better. What are you writing?
The balloon.
Oh, yeah.
Okay.
Wait, so the balloon was first, when it was put in nitrogen, was exothermic, then it became endothermic when you took it out, and it was absorbing particles.
It's absorbing. What time are we done? Like now? 3 minutes. Oh, I need you guys to do me a favor. Take one of these and pass it down. Your parents can eat out of your bowl. I want a bigger bowl.
Hurry up.
Okay, you can take a spoon or a fork.
Boom!
Did you guys get those marshmallows off the ground? Because I realized last hour they didn't, and what happened was they started absorbing energy, and then they got really mushy, and then they went into the...
I put them on the napkin. Put them there.
Oh, and there's chocolate chips in here. So another milk.
You guys get Wait. Oh, it's on your jacket.
Oh, it comes off with water. It comes off with water. Because I was just cleaning up.
On your arm and on the side.
Sorry, Sebastian. Okay.
This is my favorite class right now.
Yeah, it's kind of confusing. I don't know. I feel like she doesn't explain it enough. Like, she goes over it once
All of this and
and
only
thinks we can get it all. I mean, I get that we can go see
And
it.
you're gonna come over here. Not yet. You don't
But yeah,
do it
I
until
love
the end.
Yeah, it's like, I love this
You're
much more
gonna
than
pour.
Yeah. I like chemicals.
You're gonna pour.
And then balloon, when it was put in the air, it became endothermic, and the air became exothermic.
All of that goes in,
Wait,
and then I'll tell you.
I have a question.
Wait, endothermic.
Okay, don't pour it on my
is-
hand. We don't want to waste it. Okay, get it into the middle. Ready? That's go. Yep. Put it in. Go ahead, pour it in. Okay. Good.
That's so cool.
Okay, that's done. You can put that to the side. Yep. Now grab the other one.
This is perfect for Halloween time.
Wait, have you heard we're celebrating Halloween on Wednesday?
Yep.
No, it's on Friday.
My mom got an email from
Keep going.
Brandamart, because she's 8th grade.
Go down.
That's
Before you're done.
stupid.
All that.
Oh.
Nope, you stop. Good. You're done. You're done. You're done. Okay, pour a little bit of. Oh no, we're good.
Cooking with Smith time.
Oh, it's good.
Oh, I can smell it.
I can't.
smell it.
Okay, you guys are good. Let's put this on top.
Oh, Dippin' Dot?
Miss Smith.
Second.
It smells so good.
Okay, so get your stuff out. If you have your stuff ready.
I might need
This is just a taste, you guys.
Ask Daisy to throw them to you.
Can you throw me a bowl?
And if I
My little banana.
you like pass it on?
I didn't even get one.
Okay, she can hear us.
I'll make you some more.
Oh, my stomach hurts.
I feel like we're not
Dad,
gonna
did you get a
it.
bowl?
I'll give him a little bit.
We're not gonna get like
Yeah. Here, wait.
It does.
Wait, we're not getting anything.
Good.
They're gonna be really upset. Thank you. Okay, baby. You can eat this? Yeah. Okay.
Give me a
So cool.
That's like all of it.
Oh my god, I
I'm just kidding.
Yeah.
Can I have more?
So, Gizmo for Tuesday. Be ready to answer a gas law question. Like I might say, how did the egg in the bottle work? Would you be able to explain that?
Yes.
Yes. No. Don't memorize in here. Right? What do you know? Don't memorize. You gotta know it.
So good. That's how Dippin' Dots made. They take the drops and they fall through like a sheet of liquid nitrogen.
I love Dippin' Dots.
Okay, guys.
Miss Smith.
Once you're done, you can go. Because we're done, right? Yeah,
Miss
we're done.
Smith.
Thanks, guys, for coming.